Okay, so imagine this for a moment. You're standing on solid ground, breathing normally, feeling completely in control of your environment. Now, imagine descending, not just a few meters, not even a few kilometers, but deeper, into places where pressure crushes steel, where light has never existed, and where the rules we use to understand the world begin to break. Number 9. The Mariana Trench and the limit of human access. The deepest known point on Earth lies in the Pacific Ocean, the Mariana Trench, nearly 11 kilometers below sea level. At that depth, pressure exceeds 1,000 times what you feel at the surface, enough to crush most human-made materials instantly. This is why reaching the bottom is not just difficult, it's rare. Every mission requires years of preparation, custom-built submersibles, layers of redundancy, extreme precision. And even when everything works perfectly, time at the bottom is measured in hours. Light doesn't exist there. Every image we've ever seen comes from artificial illumination, a small beam cutting through infinite darkness. And what it reveals is not a flat, silent floor. It's dynamic, uneven, shaped by tectonic forces. Sediments behave differently under that pressure. They compress, shift, and sometimes release trapped gases unpredictably. And yet, despite all of this, life exists. Organisms adapted to pressures once thought impossible for biology, redefining what it means to survive. Number 8. Hidden lakes beneath Antarctic ice. Now imagine water trapped under kilometers of ice, completely sealed off from the surface. That's what exists beneath Antarctica, a network of subglacial lakes hidden for millions of years. One of the most famous, Lake Vostok, buried under nearly 4 kilometers of ice. And yet, it's not frozen. Geothermal heat from Earth's interior, combined with immense pressure, keeps the water liquid. Reaching these lakes is one of the biggest challenges in modern science, not because we can't drill, but because we might destroy what we're trying to study. Any contamination from the surface could permanently alter an ecosystem that has remained isolated for millions of years. So most of what we know comes from indirect methods: radar, seismic imaging, ice core analysis. And if life exists there, it doesn't rely on sunlight. It survives through chemical reactions between water and rock, a completely different kind of ecosystem. Number 7. The Mantle Transition Zone. Far below the crust, between 400 and 660 kilometers deep, there's a region we've never directly reached, the Mantle Transition Zone. Here, pressure and temperature are so extreme that minerals change their internal structure. Same chemical composition, but completely different physical behavior. And inside these altered minerals, scientists believe something extraordinary may exist: water. Not in liquid form, not as ice, but trapped within the crystal structure of the rock itself. Some estimates suggest this hidden reservoir could contain as much water as all the oceans on the surface combined. An entire ocean locked inside stone. And we've never seen it directly. Everything we know comes from seismic waves and laboratory simulations. Number 6. The Hadal Zone. Below 6,000 meters, the ocean enters a different world, the Hadal Zone. A place where pressure doesn't just increase, it transforms how matter behaves. Water itself begins to act differently. Exploration here is still extremely limited. Submersibles suffer structural fatigue, seals degrade, sensors fail. Even robotic vehicles often stop working after only a few missions. And yet, life continues to surprise us. Organisms that survive with almost no food, no light, and crushing pressure. Creatures adapted not just to endure, but to thrive in conditions that would destroy most known cells. Number 5. Deep cave networks. Closer to the surface, but no less mysterious, there are caves that descend kilometers underground, formed over millions of years through water erosion, mineral dissolution, and tectonic fractures. Exploring them is incredibly dangerous. Narrow passages, unstable rock, sudden flooding, toxic gases. Each step can be unpredictable. But inside, entire ecosystems exist, completely independent of sunlight. Life doesn't rely on photosynthesis, it feeds on chemistry. Microorganisms extracting energy directly from rock and minerals. Some of these species exist nowhere else on Earth. Number 4. The Core-Mantle Boundary. Almost 3,000 kilometers beneath your feet, there's a boundary we cannot observe directly, between the mantle and Earth's core. Seismic data shows something strange. This region is not smooth, not uniform. It's irregular, complex, with zones where seismic waves slow down unexpectedly. This suggests partially molten materials or unknown compositions. But what makes this boundary truly important is what it controls, the flow of heat from the core, a process directly linked to Earth's magnetic field. Small variations here could influence how that field behaves, and that field is what protects life from solar radiation. Number 3. The ultra-deep biosphere. Life doesn't just exist on the surface, it exists inside the Earth itself. Kilometers below ground, within microscopic fractures in solid rock. This is the deep biosphere, a hidden world of microorganisms living without sunlight, without oxygen, with almost no energy. Some reproduce once every hundreds or even thousands of years. Their metabolism is incredibly slow. Their energy comes from chemical reactions involving minerals, hydrogen, sulfur, and even radioactive elements. And here's the most surprising part. This deep biosphere could be one of the largest reservoirs of life on the planet, most of it completely invisible to us. Number 2. Oceanic crust beneath mid-ocean ridges. Across the ocean floor, massive mountain chains stretch for thousands of kilometers. Mid-ocean ridges, places where tectonic plates separate and magma rises to create new crust. But beneath them, something else even more complex is happening. Seawater seeps into the rock, travels deep underground, heats up intensely, and then returns to the ocean through hydrothermal vents. These fluids carry heat, minerals, and chemicals that reshape ocean chemistry. But the system itself is unstable. Fractures open and close, pathways shift, making it extremely difficult to model how it actually works. Number 1. Deep sediments of the Mariana Trench. Beneath the trench floor, there are layers of sediment accumulated over millions of years. Under extreme pressure, these sediments behave differently. Water trapped between particles moves slowly. Gases and chemicals can remain stored for long periods. Organic material from the surface is processed by microbial communities living inside the sediment itself. Some scientists believe these deep-sea sediments may store significant amounts of carbon, which could influence the global climate cycle. But studying them is incredibly difficult because when samples are brought to the surface, the pressure disappears and their properties change before we can fully understand them. The most unsettling part is not what we've discovered, it's realizing how much we still don't know. We've mapped the surface of other planets with greater detail than parts of our own world, and every time we go deeper, the Earth becomes less familiar, not more. And remember, the universe doesn't reveal its secrets to those who rush, it reveals them to those who know how to look. Subscribe and keep listening to the silence.